Welcome back to Made of Wires, where we are decompiling. What are we decompiling today? What do I have on my desk? That would be interesting to decompile. Maybe Gene Dark for the PSP. Oh, can we? Yeah, there we go. That was a recommendation from Radical Reggie a long time ago. I haven't played it yet, though. Just sitting on my shelf. Actually, today's going to be... We're going to start with Leg Day. The day that nobody wants to do, but you got to do it. Not Leg Day as in the... randomizer preset, but Leg Day as in doing the things that you don't want to do, even though you got to do them. If you're not familiar with the Castlevania Symphony of the Night decompilation project, you can go to soten.z.dev to see the progress on many of the overlays that we're working on. Not all of them, but many of them. And that'll take you to GitHub and Discord. I should be on Discord more, though I think I was out of town when this discussion was happening. What we're going to talk about first is a change that was made while I wasn't paying attention. And I may or may not have had opinions about it at the time. I definitely have some opinions now, and that's what Leg Day is about today. So what are we doing? We're decompiling Castlevania Symphony of the Night in a Ship of Theseus fashion. A lot of tools have been created by the decomp community to support such a thing, and we're using many of them. When I say Ship of Theseus, I mean we start with the original ship. We're replacing board by board until we have source code that compiles exactly to what the original game compiled to, but we have C source code that we can do whatever we want with, and that we have the copyright to, and no one can tell us no. Until they get... Well, I won't go down that path. Anyway, that's what we're doing. So there's a lot to this. It's not just taking game binaries and converting them to code. It's figuring out how they build, how different parts of the game relate to one another, and a lot more than that. So we're going to cover a bit of that. And today what we're doing is figuring out why segments in the Richter boss don't match segments in other bosses. So we're going to do a few things. I'm going to go over some of the background, and we'll do that, and then we'll get back to the big state machine function that we were working on earlier. Hey, Dizek, good to have you. I do have, at least in my OBS, docs now. I do have YouTube chat, so I can look one direction and see both YouTube and Twitch. Unfortunately, I still don't have an overlay, but we'll get to that. So I have a lot of splits open in Vim. Vim is my editor of choice. Usually I have a much bigger window with the much smaller font. I do this for you all. The pain that I go through for the fans, for the viewers. Oh, and if you are a fan or a viewer and you haven't subscribed, please do that. So what we're looking at right now is these three segments: eCollect, Blitchar. Let's do this right. Yeah, eCollect, Blitchar, and oh, look at that. We're not actually capturing this. Let me fix that. There we go. Let's do it again. eCollect, Blitchar, and eCollect 2. So I split Richter back in April, and in April, these were separate. I don't think the eMISC boundary was necessarily in the right place, but that is fixed. So what I did last night, I wanted to go through and map all the common functions, and I was left with these three. Blitchar actually is fine. It doesn't have any assembly in it anymore. eCollect 2 only has one function, and we'll look at that and see where or why it's different from the shared one. And then eCollect, I haven't figured out yet what is going on with eCollect. But here's the problem. In most overlays now, eCollect, blitchar, and eCollect2 are all a single segment, and they're built as one kind of monolithic file. And if we look at that source, I mean, it's huge, it's 1,500 lines. This was the first thing that stood out to me as something smells funny here. Why was this joined? If we're the PSP version, we're going to include blitchar up there. If we're not the PSP version, we're going to include blitchar down here. Biz Murphy pointed this out back in June, that usually is a telltale sign that those are separate files and that they're being compiled to separate objects. It is very common for the PSP version of a stage to have functions out of order from the PlayStation version of the game, but that just means the files were compiled in a different order. And when they're assembled, then they show up in a different order, and it's actually a really nice way of confirming where we think the different file splits are and which functions lived in files together. So this is kind of the first hint that these should be separate things. So that's not everything, though. As I was trying to match these, eCollect2, surprisingly not the relic orb function, but collect heart. Nope, not collect heart. This one here, what is this? Entity heart drop is a different implementation. We're going to look at what that is and why it's different first. That's what I want to figure out first. Why is entity heart drop different between BO6 and everything else? And my current theory, and it might not be a good theory, sometimes we know that files are definitely compiled together in the same file because the quirks of different compilers tell us that something must be static. And when it's statically linked, the compiler knows more about those files because it's compiling many functions at the same time. And it can see, for example, I know that this other function doesn't use these registers, so it's safe for me to use these registers and not push them to the stack first. I don't have to have this extra safety because I know that these things are compiled together. So then we know functions are together. Other times we don't have any information and they could be compiled together. They could not be. We don't necessarily know. And so we use that to kind of inform where these splits happen as well. There's also padding that gets introduced if several functions are together. GCC likes to put padding in jump tables and things like that so they align on specific boundaries. And those are all hints to us when there's splits and not. Other times it'll compile the same regardless, and then we just have to guess. In those cases where it compiles the same regardless, my preference would be to split more often. And that's because debugging a match for a small file is significantly easier than debugging a match for a large file. And that's the situation that I find myself in today. When you have 1,500 lines of C and data all mixed together and it doesn't match, that becomes a much harder problem than, say, 200 lines of C. So we're gonna look at this entity heart drop function first. For some reason, it's different. I don't know why. But then what I'm trying to do is collect more evidence to suggest that blitchar, these bottom three functions in this eCollect are in fact a separate, should be a separate file. And even if we don't have specific evidence, if they do compile as a separate file, I'm probably going to push to do that because it makes everybody's life simpler and it reduces build times, hopefully. So we'll see. We'll see if we can figure this out. So we already have a relatively complicated set of files. This happens as well when you have multiple versions of the game, when you have multiple platforms, and there's slight differences between them. You can't always figure out whether that code was the same or not. And so we end up with a lot of if-defs, and also not something fun, especially when you have 1,500 lines of them and you're trying to figure out what might be going on. I'm going to go down here to entity heart drop. We have a version of the function, but like I said, it's not matching. And so I want to figure out why. Sometimes it is because there are static functions that should be here that we don't have. But let's see if we can figure it out. So I'm going to go to non-matching eCollect 2 and look for entity heart drop. And we're going to go into decomp.me. I will get back to the unique Richter function as we go on, but what I would like to do sooner than later is get the base set of this overlay checked in and not have a huge monolithic check-in like I did before for reverse keep. So I'm going to grab just the... Oh, we're not... sorry. I was in decomp.me, but we might have capture issues again. There we go. This is just the B06 version of this function. We need the prize drops declaration. That is static. I don't think it's going to change how this compiles. So we'll make it extern for our case. And we don't need the macro. I'm not too concerned actually about the M2C decomp, but this is a relatively small function as well. I'm going to grab the version that everybody else is using. And we'll see what we got and what we don't. Fix my OVL export macro. I guess I could have used it after all. Might as well go down here and turn this one back into an OVL export. Our drop castle flag is dependent on stage. It's just a constant. I'm going to use the one from... I should be using the one from our top. I don't know what that is offhand. This is the one from top. And B06 prize drops. Why? All right, so 89%. So not necessarily as close as I would like. So we are doing something different. And where does that difference happen? It looks like our flag here is different. Look, maybe it's 0. There we go. That was it. So I just had the wrong heart drop castle flag, and now this works. Easy enough. But quite a difference. So obviously adding the 0 there, we'd be able to tell this with PSP as well. It would actually do the 0. No, I did not point out the librarian chair decomp. I haven't been in library for a while, so I probably wasn't even aware that it was decompiled. Hey, Mozilla. So it's possible that that was the only difference. Let's see if this is working. Oh, I have some broken things over in the first eCollect. Let's fix those as well. I think what I'm going to do is just back all these out. Get back to the normal include ASM. Each item drop for the chair. Oh, that would be interesting. Yeah, I agree. So if you're not familiar with the librarian chair, if you go under him with gravity boots and knock him up, but I think it's not, you can't hit him into the ceiling, right? You just have to kind of juggle. Maybe you can hit him into the ceiling, but you can't let him fall back down. You have to juggle him for a while, and then eventually he'll start dropping items. And there's two different items that he drops based on how long you've juggled him. Okay, so it could be that this was the only thing that was preventing all of these from being included, was having the right heart drop castle flag. So I think I'm going to try this again. And so we're gonna, I like making sure that I at least have this in my git stash. Oh, without you touching the ground. It doesn't have to do with him touching the ground. That would be fun to look at. So I'm going to try this eCollect import again. And we'll look at top. Actually, let's look at VO4. So normally these should be pretty simple. And maybe this all it was that I grabbed the wrong heart drop castle flag. So once we have that in place, then we have to go to the splat config. And this is where this tends to fall apart. So we have eCollect and eCollect 2. Basically, we have to get rid of all the eCollect 2s. And if we have a blit char in the middle of that, get rid of that too. And that just combines these segments. And make sure the BSS is coming from the C file. Let's try running again. All right, so getting a bunch of errors, including the wrong stage header. Getting text from the wrong place. Got to get it from the C file. That's what the dot means. Yeah, okay, so we're still not matching And we have some other alignment issue. So I'm going to revert that. Unfortunately, when I did that, I got rid of some other work that I did. So this build's fine. So I'm gonna all right, so git history is clean. So now we're in the same spot, but with ecollect instead of ecollect2. And so there isn't quite the same issue there where you have to define some macro before including it. The heart drop macro is just for those later three functions that we're looking at, specifically entity heart drop. So what I want to do now, and this is the leg day portion of of the stream. We're going to go through effectively one by one and figure out which one of these is mismatched and why. And that is not the fun thing to do. So this is going to take place in a couple stages. I'm going to go through and I'm going to set this up first, get this as much working as possible, that I won't have to revert later. What do we need? We definitely don't need blitchar. And so we want all of the source here. Basically, I'm going to duplicate everything. And really, this is probably how a lot of this was duplicated. But I want what I'm trying to do is figure out, is the difference between data, is it between code? So I want to exclude the code and keep the data. So we're going to kind of go through and slowly remove each of these C implementations so that we only have the assembly implementations. And the way I like to do that is by aligning each of these include ASMs with the function that it goes with. Here's our BSS right here, this item icon slots. To me, this suggests as well that this might be a different file as well. So we just gotta kind of slowly go through each of these and put the include ASM. And then we'll go through one at a time. Maybe bisect it. There's a couple different ways we can do it to speed things up. But each of these I want right next to its own file. I think it was entity prize drop. Like, I have a feeling that it's entity prize drop that is the outlier. But if it is an outlier, that's another argument. So an implementation of a function typically would not have all of the details about all of the stages that use it. So that suggests to me that it that probably is its own file split. So yeah, not the most exciting thing in the world, but this is how I debug these. People with bigger brains than myself probably have a better, more intelligent way of doing this. I cut off a dummy below. Let's go look. Thank you, Tizik. Ytop.h. Oh, yeah, copy pasta for that one. Let me finish these. So, entity dummy. No, let's see. Dummy. Yes, okay, I did. Thank you. So we're kind of restoring our original ASMs just in line with the others. And one of the things that we're going to see as well is we do need some of these symbols, and we're going to have to map some of these symbols in. Which adds to the complexity. Almost there. All right. So we have all the data now, and the data is separated from the functions. We can go into the Splat config. Let me look at a bigger one. This is better. So in Splat, we say where all the segments are. The name of the segment, which is optional, tells us where we should get each segment from. If it has a dot in front of it, it's going to get it from the compiled object. Otherwise, it's going to pull it from the assembly that's extracted from the game file. And so eventually we want to get all of these with dots or some other extension that's not one of the built-in extensions or built-in segment types. So I'm saying that we have all of our data now. So we're going to get all that from the C file. The C file pulls in the assembly as include ASM, which means it is going to GCC built it as if it was anything else in there. So no issue there. We have the one BSS, which is uninitialized data, so we have to make sure that that's coming from the C file as well. And I'm completely confident that this is going to fail. And one of the reasons is because we're missing some symbols, and we'll have to go back and map those symbols. So when we have symbols defined in C, but assembly that doesn't know where those symbols are, what those names are, we have to go and add all of those and find each one. And it's not a huge deal. It's just something that needs to be done. So we'll have this ready to go. And so what we want to look at is what symbols are missing where and why are they missing, and who wants them, and how do we map them, and when is now. So let's go. So I'm expecting compiler errors, yeah, and they're there. We have undefined references to several functions. There's at least, what do we have here? Comment within a comment. So that is wrong. An unterminated if. So let's fix those first. That was on 673. There's a ton of nested nested ifs, if defs. looks like those are taken care of. So now we have all these symbols, and we need to figure out what they are and who's using them. Fortunately, we know who's using them. That gives us some relative idea of what those are. I'm going to open this up in a new tab. I'm also going to open up symbols, the symbol table, in a new tab. And all of the symbols that this said were unique, those are the ones we want. And so let's grab those. All right, so we have what, like 10 symbols that we need to worry about. Let's sort them. Make sure that I think I did the sort unique, right? Yeah. All right, so from top to bottom, these are the ones that we're looking at. Let's start with the first one. Here's how I'm going to do this. I'm going to look at the assembly, the exported data from the file. OSPO6 data. It's going to be an eCollect. Looking at data specifically. And I'm going to do the same thing except for look at the BO4 version, which is Doppelganger 10. And these will line up. And in my exported data, I have the symbol here. And I can find the equivalent symbol Oh, and yeah, this is what I was having problems with earlier. Yeah, so what I want to do actually is look at what this data is and determine if I can tell what it is from the C file. Sometimes you can, sometimes it's less easy. I don't think I need eCollect anymore. Sorry, too many tabs open. So we have a list of, or an array of signed 16s. And this is being used in collect subweapon. So it's something around the subweapon. And I don't think we need this anymore. Originally, that's coming from a header. There's nothing there. Actually, let's look at Elric subweapon index. So it's this. I believe it's going to be this one here. And do we have other ones? Yeah, subweapon ID. So I have these two arrays here. We can kind of tell from here, this signed 8 beforehand, what is a -4 as an 8-bit value. It's going to be FC. So if we have something with FC, 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 followed by a bunch of 4s, That's a pretty good indication that we're in the right place. And here is our FCs and 4s. And to remind myself, we want this 1C variable. BO4s is not helpful to us. So I'm going to go with the Alaric subweapon index. Do I have anything else to give me hints? No, that looks like that's this here. This DDO. That's our 018F 00, which is here. So it's something slightly before that. Looks like it's one of these two, or the one right before it. I think it's this. And this becomes kind of gross too, because we have to map. Well, we have to map things that have auto-generated names to addresses that don't match from time to time. Oops, that's a semicolon there. I want to get this Alaric subweapon index. Oh, so this is just 1 through 9. So that starts here. At 3, 8. Sorry, going back and forth. Sometimes there's symbols as well that we know the addresses for, but aren't referenced directly. So I'm trying to see what this 1C is. Sometimes the addresses are kind of in the middle of an array. So you know it's an array, but the baked-in address gets set to something right in the middle of it. DDO is right before this. No, this is DDO. Move it up so they're sorted. Yes, yes, yes. The 4C probably is the weapon ID. So weapon ID is going to be 014. 14 is going to show up as E. So we're looking for 0, 4 zeros, and 3 zeros, and then E together. And that looks like it's this 4C probably, yeah. We have that one already. don't think I need this open anymore. All right, 60. Um, 60 is a bunch of pointers. And that's our gold collect texts. So these are referencing RO data. RO data, strings are often used for RO data. And my guess is that this next one is gold prizes. But we'll make sure that that's the case, yeah. That's how much gold are you getting based on index. And then sub-weapon animation prize drop. Should be a bunch of pointers, yes. Maria's sub-weapon index. Oh, that's not going to be one that we need. Because we're not in the PlayStation or PSP version of the game. Gold collect texts. It's going to be next. So expect a single pointer. No. 4 and negative. What? Negative 6. Yep. So it looks like gold collect text is either not referenced directly. Oh no, it's for PSP. That's PSP. That's right. Okay. Let's go back here. F10. Yeah. Heart prizes. Okay, so we have 3 more addresses. One of them seems to be misaligned. So here we have -1 followed by a 0. Possibly, yeah. And then -2 followed by 8. No, 0, -1. 8,000 is going to be negative int max. Possibly these explosion velocities? Yes. So that's -0.5. Maybe these are different, or I'm hexing wrong. Let's try that again. -1. -1? Yeah, okay. I'm hexing wrong. And then finally, I'm pretty sure FC8 is Big Red Fireball animation. But let's double check that. Oh no, I was wrong. No, I was wrong. Jin Shooting Star says, hello there. What language is that? So we're flipping between C, a symbol table, and the hex assembly output for this data. But yeah, primarily C. Oh, it's this array right at the bottom. Okay. This is an array of animation pointers. The only one that has a name is Big Red Fireball animation. Oh, shoot. And explosion animations is that name. So there's one more that we need to give a name to. That doesn't seem to have a name. Or at least does not fall on the same boundaries as one of the other things. Oh, no, it does. So it's right before the 1.8f. Is it this BBC? So we have how many bytes before this? 2, 4, 6, 8, 10, 12 bytes before it. That looks like it's right in the middle of this. 2, 4, 6, 8, 10, 12. Yeah, so it's like right in the middle of this symbol. I'm gonna put this in. It's gonna be wrong, but it's not going to it's not gonna affect too much. It won't match, but it'll just be an address off by 1 error. The CNC is for correct. That's right. When it is finished, will you have the full game playable outside of emulation? No. When it's finished, we'll be able to recompile the game for the PlayStation or the PSP. There are other efforts. So the game is built against the PSP, or sorry, the PlayStation SDK. So much so that when it was ported to the PSP, Konami wrote a PlayStation shim to map all the PlayStation SDK functions to PSP SDK functions. Somebody would have to write that for PC to be able to support that as well. Fortunately, there are people that are working on exactly that. So we're going to make and see how bad my symbols are. What I'm hoping is we just have address issues and not huge differences, but there are reasonably large differences here. So there is a data difference. The original one ends at E8, 16E8, and we're ending at 1738. So something else is going on here. It's not just code, it is data that's different. And that stinks. That really stinks. So I'm gonna back all this out, all this hard work, all the leg day stuff that was done, backing it all out. What we gain from that, though, is hopefully a bunch of symbols. We don't have. I do need the splat config. But we don't have our data in C anymore, so we have to revert those changes. Not worried too much about the ecollect 2. So what we have now is a bunch of symbols that we didn't have before, and I'm gonna have to go through. We can actually do this, but it's gonna be more painful to do than otherwise. But we could go through ecollect and one by one go through these functions and determine which ones are the same and which ones are not, and that's what I did for ecollect 2. We'll try one of the simple ones, like collect dummy should be relatively safe, and we can see if that still builds. Current entity. Oh, we need a slightly better header than common. All right, so that builds. So that's what I'll do next is go through basically each one of these, try to find the one, and I've been marking these as the same. I can do a little better than this. MIPS match will tell me where the differences lie, and we could do that as well. I'm not going to do that, though. We'll get to something more exciting. All right, so we'll go back to our Richter thinking function. We're focusing on the PSP version because that will tell us a little more, and so far there hasn't been a significant number of differences between the two. So I think that's going to continue on that way. We were around, let's see, that looks done. Probably around case 7 here. So we'll just keep moving down and keep going. So I was looking at the decomp. Hey Nate, good to have you. It's a lot of work in, oh, Modzilla says translation layer? Question mark? Oh yes, a translation layer. And I think my thought around this is that it probably was originally written for the Xbox 360 port and was a relatively easy thing to port to the PSP as well. So if let me go into my theory on this, and it's slightly more than an educated guess. When we look at the PSP version, it's using PlayStation data structures, PlayStation functions, all things that didn't necessarily exist in their same capacity on in the PSP SDK. And so they need to come from somewhere, and they can't come from the original. So you can play an original PlayStation game on the PSP, but that was compiled for the original PlayStation and has all of those functions baked in. And those functions, studios didn't necessarily have code for because they were coming in as lib files from the PlayStation SDK. And they're going to call into BIOS and other things like that that don't necessarily exist when you're building for the PSP SDK. It'd be fine if it was running as a PlayStation binary on the PSP, but not if you're building against the PSP binary. So what did they do? Let's see if I have any of these. We'll go with this one. Do I have any of these names? No, a few of them. So we start seeing very familiar things: sprint F, string cat, string copy. We've mapped all these already. We know what their offsets are. Set poly GT3, set poly GT4. Some of these are stubs, set mono, set stereo. They're stubs of the PlayStation SDK. So what I'm hoping here actually is that we have a kind of an independent rewrite of the PlayStation SDK for a platform that wasn't the PlayStation and doesn't have necessarily the same hardware. And we can decompile this as well. I would like to get this checked in, this split checked in. It's not building yet though. And the issue is this is the PS dot, what is the name of this file? Build PSP. Nope, not build PSP. Just PSP EU. User dir. This is the ps.l file. Are we sure Digital Eclipse shared code with Konami? Well, my assumption is that they would have had everything Konami had. And so if Konami already did this work for the... yeah, that's a good question. so Digital Eclipse did the they did the 360 port, right? Anything on there? That's a good question. So maybe it is a third implementation then of it. Maybe there's a Digital Eclipse version and a Konami version. I don't know. That's a good question. This is better than web development. Jin Shooting Star. Anyway, so we have this PS.elf has our seemingly a PlayStation SDK built into it. I don't think that it's a Sony offering. It could be. It could be a second implementation. There's so much stubbed out in it that my guess is if Sony was offering this to companies, they would have had a more comprehensive version. Let's see if we can get ReadElf to work on this. What do I want? I want all. We actually can dump this, and it probably would be a good idea to dump the symbols here. Come on. The other thing that's in this is totally interesting, is we have all of the mappings, the memory mappings for all of the binaries that get loaded as well. And this is something I think that we're missing. So there was a table basically that said, where do I map these bins when I read them into memory? There's a lot of gold here that we haven't gotten to yet. What is the what option am I looking for? I want the all option. Give me all the headers for all the symbols, all sections. A. And all the symbols. Yeah, A will give me that. Why did it yell? I feel like there's more than this here. But anyway, rebuilding this is not straightforward. There's a lot of sections in here that we normally don't include, and it seems like it would be easy to have a splat generator for an ELF file. There's more here, but I'm let me look for. Let me just try to dump the symbols. Anyway, not terribly important. I have gotten more out of this, and maybe not. Maybe we get NM. No symbols. So it does look like this maybe is stripped. Anyway, there's a lot to discover from that file. And when I have the time to look at it, I'll try to get that building as well. All right. So let's get back to this Richter. So again, this is the function that's called during the Richter boss fight to determine what Richter is going to do next. We looked at some of these states. I haven't given any of them names yet because I'm not absolutely certain that's what they are. Sometimes it's good to just give something a name, regardless if you know specifically what it is, because then you can be thinking one direction. Sometimes giving it the wrong name can be an issue as well. So it's kind of a fine line between choosing one over the other. I am going to create an enum up here, and I'm going to call it Richter Think Step. And that's going to go with along with the Doppelganger Think Step. Let me find where those are. Must be just in doppelganger.c, maybe. Oh, I just call them Think Step. Is the window frozen? Yes. And I should notice that because I have a notification on my screen, which means OBS stopped capturing. I should check console at some point and see what's going on. So we'll call this Think Step. And as we find them, we'll add them. But we were down here like around 6 or 7. I mentioned yesterday, we can kind of tell what is going on. Richter's dash. So the way that Doppelganger works and the way that Richter works is we have a virtual control pad. And Soten.dev tells you how to assign that virtual control pad to player 2 instead of it getting set through functions like this. So we can look at what the controls are, and that gives us an idea as well. What might be happening. So left, 8,000 is left, and 2,000 is right, and so we're going to be moving one direction or the other. Sometimes we see buttons being pressed. 40 is cross, so that's a jump. And we have tools that will come through and will do those replacements, so I usually don't do them in decomp.me. But as we're going through, it's also nice to know what they were, so that we can kind of sense what it is. What we found yesterday is Richter's dash is just done with the R1 button, so it's not the same command input that you normally would have to do. So we're right here around 268. I'm going to go through and some of the things we learned yesterday, I'm going to do those. So these are typically implemented as the positive side first, with the else going to the other side. And then most of these returns just fall out, and we don't have to do anything more. And what I want to see over here, I'm not worried about registers, though 269. Interesting that this is going into the S1 register as opposed to A0. I don't think that tells me anything. I think it's just a coincidence, but usually S1 is a variable. And so it is possible that this 5 is being assigned to a variable, and then the step is being checked. And at some point, we'll have to decide if that's the truth or not. All right, so continuing down, most of this looks fine. So there's a couple things that are going on here. There's an extra call that we're missing to this subfunction with a 0. And I might have that in the wrong place. Did I add that? Yes. So let's look at M2C's interpretation of this. Yeah, it could probably not a switch. The rand could be, yeah, it could be a switch. Let's go over here and see. I think it's mostly the one of the cases is missing. Oh yeah, this is it. I did it up here where I negated, and then I didn't do it here. So not negated. Unnegate the negation. And change the order of these. And then this becomes an else if down here. And the logic starts to look like it makes a little more sense. And let's go look and see if that's looking closer. We're going to get some of these moves. Not worried about those. Those will fall out eventually. But this is looking better once I fix my indentation. And this looks like it's extra. All right, so extra mask means no check, explicit check against 0. Because it was an explicit, or because it was a 0 check, we need to negate it. Do we have an else here? We don't have an else here. Get rid of the return. Another case where so case 8 looked like it was the subweapon attack. And again, we can look at what the pad is doing. 1008, that's going to be up, and 80 is square. And what happens when you press up and square? You do your subweapon. So does Richter. And you can see then how, if we were pushing the state of the second player control pad, or even the first player control pad, to pad sim, how basically we could override this logic and then control Richter ourselves. So same thing here. We're going to invert, move the else condition, the original else condition, all the way up. Get rid of the explicit check against 0. Over and over and over and over. Kind of do the same things. We have a lot of cases here, but we're over halfway through this. This one is going to be if it is equal to 0. And this is the same. On the PSP, unfortunately, if we go back and look at 289, this would have been wrong either way. We're going to see that we have the wrong immediate value here, 810 versus 1080. And that's because the enum for the pad has different values between PSP and PlayStation. Why? I don't know. We saw this earlier. Does this all look good? From 298 down. One extra thing on 308. Oh, I forgot to get rid of the not equal to 0. We're setting pad sim to pad down. And then down here, we're setting it to down and square. This is actually going to be a or equals pad square. And we saw that yesterday as well. I'm going to undo that. We'll go down to those lines. So we have this or down here. The PlayStation just optimized it to an assignment. But we don't have an optimizer enabled for the PSP. So we don't have to worry about that. We see that the code wasn't or, and it optimizes to the same thing. And this is the same logic again. Is this really duplicated all these places? And would you write your code this way? This is actually duplicated all of these places. And somebody did write this code this way. You can say, man, I would never do that. I would never write code like these Konami devs wrote their code. That's easy to say, but they also created one of the greatest games of all time, right? Writing their code this way. So pedantic code reviewers can take a seat. Desic is saying it might be worth looking at this 5A4 function, yeah, and get arguments there. Yeah, definitely. Passing an enum as an argument or setting an enum type is fraught with peril. We do it in some places, and I think this version of GCC. So we want a matching decomp, which means we can rely on the compiler features of the compiler that compiled this game originally, which was a version of GCC that's very old. Fortunately for us, as far as I can tell, an enum is always a 32-bit value, but that's not guaranteed by the C spec. And if you need absolute binary compatibility, it's a little dangerous to specify a enum as a argument type, because it may turn into a 16-bit, 8-bit, whatever it is. The only guarantee you get in C is that the type that the enum gets converted to will have enough space to hold all the values of that type. And so I've kind of stayed away from it. But in cases where we do use it, it works, and M2C will actually see that it's an enum type and put all those enums in for you, which is also very convenient. Yeah, so there's always kind of a trade-off between the two. Let's do that though. How much do we have? Oh, we're getting close. We're getting close. 335. This looks like it should have been a not. And we're up to 89%. Let's do a spot check on the PlayStation. Absolutely no difference. So everything that we did when you get an optimized version of the game doesn't make a difference. That is nice, though, that we have multiple versions of the game to base these changes on, because it does help us to find some truth. I'm going to switch this version to be an equals. Maybe not. Yes. Nope. Oh, this is wrong. Oh, that's why it's wrong, because I made it wrong. The things that'll probably help us get a better match on the PlayStation are any variables that we find. And a lot of this similar code came from go-tos. And if, as we are changing one place and not the other, the go-to, like, deduping logic doesn't hit. And so we can kind of move away as until we get closer. Fred's saying that the super ghouls and ghosts code is copy pasta. A lot of this is copy pasta too. And if it works, it works. Uh, Fred, I completely agree with your sentiment, and I don't think it was just games. Um, I think that's kind of it's a very gross overgeneralization, but the terse optimization is something that I don't think you would ever see in Western um, games from the time. Like if you had like super optimization, it would be in specifically performance critical area of code. In a lot of this code, you see like these wacky optimizations in just like very standard uh, functions, and then you see other places where you think it should be optimized and it's not. I don't know. There must just be some different mindset in. Um, I don't know if it was in like programming or engineering education or what exactly from that time, and maybe it's still true today. I don't know. But I agree that the game design is incredible, um, and it the way that the code is written versus the way that the game is designed really makes me like wonder how it ever got finished and how and it could be like work culture, work ethic that has something to do with it. I think if if you found yourself with similar code as an American engineer, you'd say, I'm not working on that, and you'd leave. And I think in Japan, people are more used to the grind. All right, so we have a jump for this inner switch that is, I think that these are different. Yeah. So if we're not a 3, 2, or 1, we should be breaking to the end, but we're not. So let's put a default in and throw the break. Maybe throw a return there. Yeah, this is odd. So if we um, if our default case is hit, returning early gives us what I think is going to be a more similar um, exit point. Oh, this is interesting. It's not quite the same. There is a function that gets called at the end. So that is wrong. Oh, oh. So we're not just breaking, we're going to be calling this with. Maybe? Maybe we're falling through? I'm going to go. I'm going to check these first, and then I'm going to go look at those other ones. So this is again like a GCC optimization that we miss some of the subtlety. We're explicitly checking facing left. So if we're facing left and we're greater than hex 80 or 128, do this. If we're not facing left and we're less than hex, or sorry, less than 128, then do that. GCC recognizes the inverse here and that it doesn't need to do the check twice. And so it optimizes it out. But it's there. It'll compile to the same thing. Again, this is one of those things, just like we're talking about, where there is a simpler way to do this, but that is not what was chosen. And why is that? Ooh, did we just go down significantly? Oh no, we went up significantly. If there's a return in the middle, I like changing that to an else, and usually that will do the same thing. Same thing here as elsewhere, where this is an or equals. Our linter will come through and change that to the enum. Christiana is saying, if you had a big switch like this, you would make each one a function. Yeah, I mean, I think if you look at modern emulators and other things like that, having a dispatch table for each of these would make sense. There's we don't think that there is a lot of inlining in this code, and the settings that we have for GCC are pretty reliable and produce a match. Yeah, this was a fall through. So I don't think I don't think that there's a case. We do see cases where it looks like there's copy paste inline. But I don't think there's function inlining necessarily. It's good to remember that this was 1997 with a compiler from 95, 96. And so the things that we think about commonly as like common optimizations that people might do, they just weren't standard. A Castle Flag 95. Let's see what that is. Ah, Shaft's Orb. This is a I always like this one. This is a fun GCC optimization. Two fields are right next to each other, step and step underscore S. They're both 16-bit. GCC says, let's do a 32-bit read and do it all at once instead of doing two 16-bit reads. And so you get this interesting... we could actually... We have a macro to emulate that behavior, but it's actually this step S. That's always a fun one. Always a crowd pleaser. Anything here? This one actually is ending up out of order. Oh, because assignment instead of equality. Thank you, Christiana. Yeah, that always makes me smile when I see that one. A time that the optimizer does something that I would actually want it to do, which is produce code that's better than the code that would have been written but still makes sense. All right, so that's it. Let's see. I'm gonna take this. Back. The main thing that is wrong is we have a bunch of variables that look like they're missing. We'll come back and fix those, but let's see how the PlayStation looks. Ooh, worse on the PlayStation. Not ideal, not ideal. So there's that happens. I'm not too concerned. There's a couple things that might be going on. I'm going to work out the variables because I think that I have some places where global pause versus player distance are mixed up. But let's go through the other instructions and see. So we have a register issue here. Register issues maybe because the wrong variable is being used. Um, 212. So this looks similar to that other case where the hex 19 is being loaded earlier. It's being put into V0. Sometimes this happens when you are using a variable. The optimizer puts this in and, or sorry, the compiler puts it in, assign this to V0, and then the optimizer doesn't catch that it's a dead store. We're throwing the value hex 19 into the register V0 and then immediately overwriting it. So this store to V0 does nothing. And so that suggests that it's a, let's see if we can kind of force it. What kind of variable do I want to, let's make it a sign 16. We'll call it step. And we were here on 211. And let's go right about here. I guess we want this to be, let's move this up. We still don't get it. And we could do something a little more. We could say that this is volatile. No, that's not going to do it. Sometimes you can force the write. We'll go back to the PSP and try to figure that out. I think that there's going to be something like that, though, that is missing. And the PSP is now closer than the PlayStation version. Usually when you... Oh, what did I do? There was something here that I changed. I don't know. All right, so we'll go through and fix registers. So there's different types of registers that are for different purposes. They're all general purpose on MIPS, but they're intended to be used in particular ways. V0 and V1 are for return values. A0 through A5 maybe are arguments. S0 through at least S7 are for variables. And then are there T registers too? Yeah, I think there's T's for temp. And so these are used different ways by different compilers. A lot of times GCC and MetroWorks will use A0 and the A registers and the V registers for temporary or ephemeral values that aren't assigned to variables if they're needed in the middle of a calculation. So the way that I've tried to figure out where have I screwed up and am I assigning things to the right variables? One, in MetroWorks, sometimes ordering matters. Sometimes it doesn't, sometimes it does. It's kind of hit or miss when that does. But I'll select what I think are the same variable registers in the original assembly and the one I'm generating, and then just scroll through and try to find situations where one is being used and the other is not. And if they're always being used in the same place, like here, 146 is wrong. And let me remind myself what S1 was. Global pause X. Then I know that I got the wrong variable. And most of the time it makes sense as well what is missing. So on 146, this should have been player, not global. And let me go find my... It was S2 and... Oh, doing that looks like it aligned those registers. And so now S2 is the same between both of them. And that's a nice property to have. So S2 was the global pos X. So I'm mostly going to worry about the positive cases. So here on 254, this assignment is actually using that register. I don't believe that that's a real variable assignment. I could be wrong. I think at this point that variables no longer being used, and so the compiler decided that it would start using that register again for ephemeral purposes. Now here we have another one down at 489. I think this is going to be the same thing. All right, so then going back to S1. S1 is our player distance X. And I'm just looking to make sure that every time S1's used on one side, it's used on the other. So 243. And then at this point, by 269, it's never used again. And I think this is the same thing where the compiler is just, it has put that back into the cache of shared things. All right, so the next thing to get registers to align the way that I want them, let's check this again on the PlayStation. I think this should be a little better, slightly better. Is to look for things like this, greater than equals. Usually it's a less than or a greater than, and greater than equals is not often used. It is occasionally, but not always. Nothing like that. That does significantly change registers as well. And one more peek at M2C and what it produced. What I want to do is look up here. It's possible that we have some types wrong. Temp S2 possibly is a sine 16. Improves a bit, and it's possible that this is as well. Player distance X. That does not improve. And then there was one other. Oh no, yeah, I think I've covered all the areas where variables were being used. And let's look again. Worse. So GCC likes that being a sine 32, which I'm fine with. Let's go look at that X19 case. I'm going to look at that on the decompile. One thing that we might be missing, and Dizek pointed out that we could look at this 5A4 function, which I think is probably worthwhile. Is whether or not that's static, and we'll take a look at that in a second. There may or may not be, what should I say? If we get a very close match on the PSP, 9 times out of 10, it will match completely on the PlayStation. And that's why we look at the PSP. It's an unoptimized build. It gives us more detail, and usually compiles to the same thing. Not always, but usually. All right, so I wanted to look at this 19 down here and see if there might be something else going on. There are these explicit returns. I was hoping that those wouldn't be relevant, but they might be. But I think I'm going to start with this A14 function as well. And it might be that this has to sit for a bit and stew while I find other things. Oh, this is awesomely short. All right, so we don't even have to decompile this or use decomp.me for this. We'll do this one by hand. Let's find where it is. Come on. Come on, you can type. You can paste. One thing we won't get out of this necessarily is the types, but I think we'll be fine. And this may be the secret to why the PSP is behaving the way it is. So what do we have here, and why do I think we can do this without a decompiler? We're looking at 2 registers and assigning them to 2 global addresses. The first one is the A0, taking the value of the A0 and storing it to the memory address here. C38, if we remember what we thought that was, C38 is the Richter think step. And then 3CC is the other address that happens to be in this function as well, and that is think step S. Think step S is getting assigned the register 0. The register 0 always has the value 0. So we're a function that takes 1 argument. Those globals right now are signed 32s. It's possible that they're signed 16s, but I'm going to assume that they're signed 32s for now. GCC won't care. So we do need those forward declarations. And the implementation of this is going to be a void. We're not returning anything. How do I know we're not returning anything? Because we never write to the V0 register. And that's where the return value would be. I'm going to say sign 32. This very well might be a sign 16. And then we're just assigning super easy. And that matched. So now that we have this function, we can go back to the PSP version. Not only is this going to be visible when the compiler compiles this, but it's probably going to be static as well. And having a static function that's also visible occasionally, but not always, affects the compilation. We're going to get a slight issue here because some additional code is being produced. And decomp.me doesn't know how to handle that. If we look at object diff, it can somewhat figure that out. But then I want to go down and see, like, is our situation with the moves improved? It's not, which is kind of a bummer. I was really hoping that this would clean up those. Bummer. Hey, Supreme Quetzal, good to have you back. That's where we're going to end it for the week. We'll come back next week and see. Oh, 109. Interesting. No, not interesting. We'll come back next week and see if we can finish this off. Yeah, definitely some control logic that isn't quite right still. I'm looking at this and it looks like this falls through in the default case. Falls down to here. Oh, where's it falling to? 139. So yeah, not perfect yet, but we'll get a little closer. Bummer that the inlining of this, or the ability to see that didn't help at all. One more time, we'll take a look at PlayStation. Still 94%. All right, we'll come back next week and finish it off. So we've been working on the Richter logic for the Richter boss fight, and getting pretty close to finishing that off. And we're decompiling Castlevania Symphony of the Night. If you want to know more, go to soten.z.dev. Appreciate everybody showing up. And as always, thanks to the people in chat for catching my mistakes early. And I will catch you all next week. Adios.